So far, we've only looked at individual types of behaviors. What I want to focus on now is what happens when a population behaves in a particular way, and particularly as a unit. So this is something known as sociobiology. And what we look for in sociobiology or social behavior is essentially evolutionary theory explaining how a population behaves. So what we look at are these behaviors are adaptive. So that means that evolution is selecting for them. Well, what kind of behaviors are you going to select for in a population? Things that are like survival, food, habitat, protection, right, of offspring. So take a look at this. When we look at cost and behaviors and benefits and behaviors, what we have to think about is that social behavior really is survival reproduction kinds of ideas, but there are costs to that, right? If you're living as a large population group, you're exposed to all kinds of diseases, parasites, mites, all kinds of things, right? And if one has it, they all have it. The other thing we have to worry about is the weakest member. So if you really are going to have a strong social network, you don't leave the weakest member behind, but that weakest member will slow everyone down, right? These are huge costs to a population, but there are also huge benefits. So group defense, right? So even if there is a weak member, there's a group there to help protect it. What about conservation of energy? Right? Think about when geese fly in a V formation. Why do they do this? Do you know? Well, they actually fly this way because the air currents change, and it actually allows the individuals at the back to put in less effort. So they actually rotate this V on a regular basis and share that energy drain and help these migrations go much smoother. Warmth in the wintertime. Okay, so we actually look at the idea with like penguins and so on, that they huddle together, right, to stay warm. But frankly, are you going to mess with something that looks like this? Okay, so this is a population of muskox. They put all the babies behind, and you can't see them. They're all hidden in behind the large adults to protect them. And if you come face to face with this population, you certainly are not going to mess with the babies or any of them, right? And these kinds of social behaviors often result in what we call dominance hierarchies, and, you know, loosely phrased as pecking order, right? So who's in charge? Who's mating with the females? Is there a single dominant individual? Right? Okay. So what's going on in this population? Typically, we look at a very strong ranking system in these kinds of populations, and it really becomes even more advanced when we start looking at territoriality. So these prime, very strong individuals will actually set up territories to decrease competition. And this competition can be just for mates, it can be for food, it can be for habitat, shelter, what have you, but it decreases competition. Because what we look at is that competition is bad for everyone. Even if you're the winner, competition is still bad. Okay? So why? Well, we look at competition as being a drain of energy. If you have to fight all the time, if you walked into a restaurant and had to always fight for your food, you may not spend so much time at that restaurant, right? It's going to be a drain on you. There are easier resources. So competition becomes very, very important. And communication. In these social groups, without communication, there is no ability for the organisms to warn each other, to look for mates, to make sure that the population is safe. So the signaling is huge at making sure that the signals are sent and received and that everyone knows what's going on. We're watching for predators, we're watching for availability of food, we're making sure that the offspring are safe. Now, these are basic kind of structured populations where we look at it kind of a dominant sort of hierarchy with territories and good communication. But we can also look at what we call eusociality. And essentially, this takes population living to a very different level. Essentially, in this case, we look at a caste system. So do you remember back from social studies what a caste system is? So essentially, this is complete division of labor. There will be workers, there will be breeders, there will be individuals that clean the hive or the nest, and never the two shall mix. We don't see overlap between these, but what we see instead is a very functional society. In this case, these are naked mole rats. Very caste system. You may know better though, bees, honeybees in particular, some wasp species. All of these live in a very structured environment so that the benefit is to the population and not to the individual. So the goal is always to make sure that the population survives, even if it means sacrificing some individuals. But the goal is the population. Now, when we look at this in other populations, we don't see so much of a caste system, but we still see competition and divisions. So when we look at things like altruism, we look at the ability to make sure that another individual survives. Now, typically we see this in humans, primarily when we look at heroes on the news, individuals that went above and beyond for people they don't even know to save them. We see this in fire ants, where they will actually sacrifice and make sure that the rest of the population is surviving well, and will actually carry out very risky behaviors so that another individual can survive. Now, most of the time we see this towards relatives, but there are instances where this altruism for relatives, things like I have here for you, are spadefoot toads. They will actually kind of just nip at their siblings like they're having fun and playing, but they will eat completely other tadpoles. So they're producing this altruistic effect in that they're not eating their siblings, right? But when we look at reciprocal altruism, this is actually the idea that you can be altruistic to non-relatives. We see this almost exclusively in humans, but there is actually some examples of it in vampire bats. But what they see is the vampire bats will tend to be altruistic towards non-relatives only if that individual has helped them before. So it's an interesting kind of relationship where one is going to help the other, but they expect something in return. So, like we said, pretty uncommon in the animal world. These are strange behaviors, they're different behaviors, but what you have to link in is how does the behavior make the individual or the population more successful? You should go back and think about all of these behaviors and say, okay, for this behavior, why is that individual now better suited? Why does he survive better? Why is the population surviving better? Because of that behavior. In nature, that's the focus.